Welcome to the AI Think Tank podcast, the future of intelligent systems, machine learning, and data science. I'm Dan Wilson, coming to you from Seattle, Washington. Today, we're joined by Bhupinder Bhullar, the CEO of SwissVault. He and his team are pioneers in sustainable high-performance data storage, redefining how organizations around the world think about energy efficiency, security, and long-term resilience. Their latest announcement on democratizing shingled magnetic recording drives marks a turning point in storage accessibility, making capabilities once reserved for hyperscalers now available to enterprises and communities everywhere. We'll explore what this breakthrough means for AI, sovereignty, and the future of sustainable data infrastructure. You can visit their site at swissvault.global. Welcome to the show, Bhupinder. How's it going?
Really well. Thank you, Dan. Thanks for hosting me. That's wonderful to see you again.
Yeah, you too. It's been a minute. I know you're in Toronto right now, and out here closer to me than you usually are in Switzerland. So this is great. We could get our times closer. There's been a lot going on in the news for data storage and AI needs and a lot of things right now related to what we're going to talk about today. And it's exciting. When I saw your press release last week about shingled magnetic recording drives being supported by SwissVault, I was very excited. And for those of you out there, shingled magnetic recording is a type of hard drive recording where it's like roofing shingles, where these magnetic tracks are kind of overlapping each other, and it provides up to like 20 and 25% savings on actual capacity. In some cases, you get more of it because of this. And Seagate originally shipped these in 2013. And so they've been around for quite some time, but SwissVault is now able to handle these drives in a way that usually only hyperscalers and other large data centers would have the capabilities of doing. And so this is really exciting to hear, and so there's a lot to this, and so I'd like to show people what SwissVault is actually doing, and what your product is. I know you guys have been doing this since 2018, and I know your original focus was on cryptography and encryption. And so, with that said, the offerings that you guys have been making for the past few years that I've known you have been formidable and exciting. And instead of me using my words, I'd like to actually show what's going on with your technology and where we are today at SwissVault.
Thanks, Dan.
Yeah.
And so basically, as you know, in our DNA, the
Mhm.
DNA is about long-term storage. How can we help organizations and individuals manage their data with privacy for their entire lifetime, so 100 years, and do so with a low impact on the environment? And
Mhm.
along the way, you have to, when you're solving these problems of making this possible, you come across a couple of different hurdles. One is that inevitably files will get corrupted, right?
Mhm.
And so if you're trying to help someone maintain data for 100 years, you have to build a file system that will automatically correct those files so they're always pristine, the data is always pristine. And the second thing that's going to happen, another thing that's going to happen for sure, is that the disks or the media will break, the servers will fail. This is
Mhm.
because of some mechanical or electrical problem.
Mhm.
And that data technically could be lost if you don't take that data off that drive and write it somewhere else. Or if
Mhm.
the drive is broken, recreate the data somewhere else. And right now people have to run around doing this manually. And that's one of the things that we solved as well. For 100-year data storage, files that get corrupted are automatically corrected, so the data is always correct. When
Mhm.
disks are broken, the data gets written somewhere else. So those are major headaches that major data centers always have to plan for, and they have teams that are already sitting by to fix those problems. But we do that automatically, so someone has a turnkey solution basically to run a major data center on premise, that kind of thing. So
Yeah, it's incredible. We met a few years ago through my MIT think tank that we used to run for our cohort, and
right, yeah.
it was phenomenal to see what you guys had cooked up then and how, energy efficient and space efficient the technology is. But even now, there are so many new things that have come together for Swiss Vault that I think a lot of people are going to be very happy, to find out that their small business, can afford on-prem with the same resiliency, if not better than a data center. And
Right, right,
at a magnitude of an order of magnitude lower in power consumption, along with a smaller footprint and a nearly silent and very cool operation, which is
right.
something that everyone needs right now with this much, hype and actual investments that are going on with energy and planning for AI data centers. You can pick a week, pick a day. There's something coming out where like, yep, we need more power. We need more power.
We need more power. Yeah,
In this case, I mean, it's we've been brute forcing our way through this. All the
yeah.
hyperscalers are just like, just add more, just add more. We're going to reach AGI. But
Right.
really, without AI, there's a dire need for this technology, and the way SwissVault does this and provides it is phenomenally different. And I spent, I don't know, over 4 months working with Malaysia's National AI Office working groups for AI sovereignty. And when I provided my reporting for what would be regional providers of anything even close, SwissVault was on top of every category, and it was fun. It was so drastic, right? And when we show everyone today what's really under the hood, it's almost hard to believe for some, until you see it. But a lot of people say, I don't believe it. There's no way that's possible, but it is, and you guys have been doing it for a while. And it shouldn't be a secret. More people need to know about this, and so that's one of the things we want to show off today. So yeah, I mean, you're also, involved with the New Jersey Big Data Alliance.
Right.
You have a wide array of reach when it comes to different sectors, from agriculture to aerospace. I mean, I've seen a lot of the case studies and projects that you've been involved with, and it's immense. But I'm always excited when there's a new press release from you guys. So,
Thanks.
but yeah, so what else are you seeing right now? What concerns is SwissFall able to address on top of just that? Because you're using your own file system that you developed that actually handles very large amounts of data. Care to tell us about
Yeah.
that?
Well, basically, the three things that are challenging now as a result of the explosion of AI is the ones you just mentioned, the power consumption. So you're quite right. There's a massive need for more and more power. And number two, the storage media. You got to put that data somewhere. So you got to put it on disk drives and servers. And the
Hmm.
third thing is you need talented people to manage that data storage, right? Talented people to run around and operate all those equipment and keep it efficient.
Yeah.
And those three things that you hit on are the ones that are of very limited supply, basically. Not enough power, not enough storage media, and not enough talented people.
Mhm.
And so we kind of take care of some of the problem by reducing the amount of energy required. So you don't have to store as much data. So that's less volume. So use less equipment, and you run that equipment to the end of its life, basically, so you can use it 3 times longer. And then the third thing is automating all the stuff I mentioned earlier with
Wow.
the data migration, fixing files, fixing disks. That takes a major headache from most data centers in their planning.
Yeah.
So the Vault file system has a couple of key differentiators or the key benefits that it has. One is that what the Uptime Institute calls high availability or uptime, and then label that 17 nines. 99.999 17 times, right? And
Mhm.
so 70 times uptime, that's what we guarantee by just using our erasure coding file system and with a very low footprint and very low cost, basically. The other thing is that you reduce the data volumes under management, as I mentioned earlier. That means that you're not using as much equipment and much servers or disk supplies. But now, when you're using these low performing disks, like spinning disks, they're known to have low speeds for reading and writing data from the tracks.
Mhm.
And in fact, that's why people want to go to SSDs because they're already 5 times faster, or NVMe media because they're even faster. But what we're saying is with a parallelization and distribution of the data that we do with Vault file system, we can increase the speed of the read and writes from these disk drives, spinning disk drives. So you can use low cost but get high performance. And
Hmm.
that's important because remember we talked about earlier how there's just not enough media to store all the data. So
Right.
people many years ago were calling the death of tape drives or spinning drives because they're saying SSDs will take care of everything or
Hmm.
NVMe will take care of everything. But the cost of NVMe and SSDs is not just one of the factors, but the ability to produce the volume of media to manage the data. This data is just growing through the roof,
Right.
and then you need the capability of to manufacture tape drives to meet that capacity, plus all the SSDs and HDDs and NVMEs, all the media is combined, and so that's important. And you mentioned as well that correctly that bulk file system can use any of those media, all of them together, all
Hmm.
at different volumes,
Yeah.
and that flexibility inherently gives some end users, and a lot of end users, the ability to, scale up or scale out,
Right. Uh,
and be flexible. Yeah.
Yeah, the original, I remember watching the demo of this video, and I'll just explain it to the audience. It was a monitor screen showing a high definition video that was streaming from a banked array of disks using the Vault file system.
Right.
And they were unplugging, they were taking them out in real time, and this thing never had any blips on the screen whatsoever. And reinserting even brand new drives that weren't formatted, and they were reintroduced into the array. And but you can do this with a mixture of drives too, as long as they would fit in those bays. You could say, oh, here's a SSD, here's a platter drive, here's an SMR drive, uh, and all the person needs to know is how to safely plug in and unplug drives, and
Right.
it handles it on its own. It is just that easy.
You'll configure that drive, and it will put get the drives all prepared for you in your array, so that you can just start recording data on it. Yeah.
Yeah, yeah,
So the old way that we manage data was with a lot of file systems like ZFS,
mhm.
are using RAID, and RAID is basically can have one or two parity and disk drives in the same server. But if you are worried that if you lose a server, you're going to lose all your data, then you want to back up the data to another server, basically. And
Mhm.
typically, most governments and other organizations that want to maintain high resiliency will make two backups of the data. So two backups basically equals to 200% overhead of your file system.
Mhm.
And remember, so now rather than 1 terabyte, you've got 3 terabytes of data just to manage that one file of 1 terabyte. And your speed limit is restricted to the one server that you're accessing.
Mhm.
And so what we've stumbled upon was that with erasure coding, we can not only lower the data overhead, so reduce that data hardware overhead dramatically, but increase the speed by using all the servers in parallel, all the drives in parallel. And that doesn't necessarily mean that you need to have a high energy cost, because we'll show you a little bit how we address that in the future. So this is how the animation kind of shows how the data, when a file gets brought into the system, the file manager chops the data into pieces
Mhm.
and then creates parity pieces. So here's the data coming into a server. The server recognizes it, chops it up into pieces, and distributes it among the network of servers or disks that are available. It could be only on one server, or it could be on many servers, and it could
Wow.
be around the world. It doesn't matter. And then the blue pieces are basically the parity pieces. The
Mhm.
parity is a mathematical projection of the data. It's not a copy of the data. And so it's like a formula A plus B equals C. So A and B are your data chunks, the D1s through 6 that are shown here.
Mhm.
And the C is your parity. So if you're missing a piece like B, you can
Mhm.
go to C minus subtract A, and you
Mhm.
get your B. Basically, the same formula mathematically. A plus B equals C, C minus A
Right.
equals B.
Mhm.
And that's basically what the beauty here is. So we've written the data much faster, and we are able to recreate the data from the pieces. That's what you saw on the video we did for the
Yeah.
U.S. Air Force, and the data gets rebuilt and sent back to the end user.
Nice.
So you can tolerate multiple failures. And in summary, rather than maintaining 200% hardware overhead to manage the file, we can take that original data and break it up into 120 data chunks, six parity chunks, and we're down to only 5% overhead. 5% overhead means that you can store more data on the same disk that you have.
That's
And
right.
number two, your parity of six means that you can lose a lot more pieces, a lot more disk drives or more
Hmm.
servers before your data is at risk. So you've increased the resilience of your data storage platform.
Yeah.
And the 120 data chunks means that you're going to access the data much, much faster
Hmm. Yeah.
because
That's
everything's happening in
incredible.
parallel. Yeah,
That's incredible. I mean, this is in light of all this. I mean, mathematical optimization is the name of the game, and that's what Swiss Vault did. And you talk about, costs of things and then the space and the possibility. You guys are making it possible with your optimization and your algorithms, and it's incredible. I mean, this is the call right here to everybody out there. Would you like to save some money? Yes. Okay. Would you like to make it possible to have on-prem architecture, and provide your own compute and storage attached? Yes. I mean, especially again with the need for it, and then of course policies, and the other
right.
needs for it. Not just the physical. Hey, I'm an engineer. I need to be able to put this back together, and
Mhm.
recover data. But it's phenomenal, and I have so much respect for this as someone who worked with device forensics for 18 plus years, and for a lot of companies. And you guys are very secure about this too. I'm very just very
Yeah,
excited to see what's next here.
we have applications in many organizations. One of
Hmm.
them is like with the healthcare data, there's 10 petabytes of raw data that they had, made two backup copies, and we demonstrated that you can do eight data plus four parity on these
Hmm.
same servers, the Dell servers that they have.
Hmm.
And we reduced the data volume by 50%. So they can now
Oh
store
yeah,
twice as much data.
right.
The data comes back eight times faster for their analysis.
Uh-huh.
And all the files are kept in a way that, there's always a checksum done or to maintain the correctness of all the files automatically at
Right.
any time they're accessed.
So, are you saying that anybody with an existing data center or a small bunch of rack servers, let's say, could just take and could license the Vault file system from Swiss Vault and install that onto their hardware without any other extra hardware? How does that work?
Absolutely,
Oh,
absolutely.
wow. Wow.
That and
Okay.
well, but basically, what happens is that most data centers will have servers that will be able to run it. Absolutely, and they will be able to extend the life of these servers and disks much longer. So what we sometimes tease some of our clients say, you're throwing out these old disks and old servers.
Hmm.
Don't do that. That's
Yeah,
ridiculous. Don't do
that's
that
right.
anymore.
Hmm.
We can put Vault file system on there. You get extended life. You'll be able to use better your resources longer, so you'll reduce your capex costs. You'll reduce electronic waste,
Hmm.
and so they're always in disbelief. But when they start running it, they see that it indeed is the case. So
Yeah, that's it. And I mean, that's just, and this is just the start of the money savings here. This is just the start. I mean, at the ground level, if you said, "Hey, I want to use Swiss Vault, but I'm not going to use any extra hardware from them. I'm going to use what I have." You get this
right.
immediately, this amount of performance, resilience, and energy savings all around, right? Heat and energy. This is phenomenal. Okay.
So
Uh,
and then I wanted to throw this piece in is important. And that is the resiliency that we have to think about in terms of our network has to extend sometimes beyond our own building.
mm,
We might have to. We were challenged once by a healthcare organization in Europe that said, well, what if the whole city gets burned down? What will happen to
mhm.
my data? I was thinking, well, if your city gets burned down, you have a bigger problem. But
Yeah.
basically, the idea of continuity for government is important and society in general. And so the challenge was given to us, and we started to design the file system so that we could distribute that data not only in that same data center but across the world. And so here we did an experiment where we had access to Lumen's data and network. They give us access to a data center in Seattle, Phoenix, New
Hmm.
York, and London, and we connected in one namespace. And because we took a single video file, we chopped it up into 10 data pieces
Hmm.
and 4 parity pieces. We were looking for that data to come back to us in parallel. So the typical speed of the data is about 15 megabytes per second on that network.
Hmm.
And we're measuring 150 megabytes per second because we're doing everything in parallel. So we're asking
Yeah.
for pieces to come back to us in parallel,
Hmm.
and that gives us a much faster speeds.
Yeah, that's
So and
better.
now,
That's much better. Yeah. Wow.
now you can extend
Wow.
this. So we call this the edge. You can extend it to the edge. And what's the extreme edge? Space. Space is extreme
Yes.
edge. So I'll just point that out to you here. We started building for the idea that you can build it in space. So the here what you have is a network of satellites. You can't send a repair van to that satellite to fix any disk drives, but
Hmm.
you have to be able to. But with the distribution that you can do across the satellite cluster by chopping up the data and spreading across the disks across the whole cluster of satellites, you
Hmm.
ensure that even if one or two or three satellites go out of range and you can't access them, the other satellites will complement each other, and be able to get the data back down to the ground station of
Hmm.
the Earth connection. And you can, if satellite one is in connection, you can get the data from all the other satellites, which may be out of range of that ground station. And or satellite eight comes in play, et cetera, et cetera. So it is a very distributed network, and all the partners that we presented to, who are building in space, are very excited about this
Yeah.
and looking
Yeah.
at our designs.
This is so important in terms of just aerospace communications and you know uh, a different need for resiliency in a harsh climate or a lack of a
Well,
climate
I mean,
altogether.
well,
So
think
yeah.
of it as extreme edge, and the extreme
Uh-huh.
edge.
Yeah.
If our system can work in the extreme edge, it can
Hmm.
work on Earth and provide a lot of value in
Oh.
terms of self-managing, low energy, and low data volume, so you can store more data and faster data processing and faster data movement, so that and data available everywhere all the time. Those
Hmm.
kind of things mean that we'll get a much more better performance of our network.
Yeah. Oh, definitely.
Um, Here's that video that you had mentioned. I can play it again for you if you like.
Yeah, let's take a look.
Okay, so what Dan was mentioning earlier was that these are 10 or 20 disk drives that are shown in Grafana. And Grafana is going to refresh every 30 seconds, but we're going to play a video here that's going to be chopped up across these 10 disk drives into 10 data chunks, 10 parity chunks. And then we'll see a little video of the server where the disk drives are being removed to simulate the failure of the disk drives. So this is the video that's playing,
Hmm.
and it's been distributed across these 20 disk drives. So you can lose 10 drives and your data will still be fine. So the individual is removing the disk drives here on the bottom right-hand corner.
Yep.
And what we're seeing is that when the drives are disconnected, the the data is no longer available to the file system, and the file system scrambles, gets the pieces that are missing from somewhere else,
Hmm.
fixes the file, and sends it to the user so there's no interruption.
Yeah. Yeah. Really good
And
parity management. The parity management is everything here. This is
right,
yeah. And you've been able to show this off. This isn't just a video somewhere. When you're out and about, if you happen to be at a trade show and you find Bhupinder, go talk to him. You were telling me
exactly,
about a briefcase size setup that you had been traveling with here recently too. So
yeah.
very
That's true.
exciting. Yeah.
It's another version of this server system that we have.
Uh-huh.
So I'll pause that. So basically, going back to the satellite stuff, what we're trying to demonstrate is that you have high resiliency so you never lose your data. And if should a server go down, like one of the satellites here, you can launch a new satellite and connect it, and you keep running, and then your data center will keep growing and expanding.
Hmm.
And so you're quite right. One of the things we demonstrate is that the resiliency, but also the low sort of size, weight, and power. And that the hardware I showed you fits really well into a satellite sort of configuration because you
Hmm.
can't launch a lot of weight in the rockets that we have
Oh
currently, the
yeah.
payloads.
Hmm.
So, so by reducing the size, weight, and power, we're able to build for space-based allocations. I can, so this is one of the other things that we built was responding to the community and the community need. We
Hmm.
recognized a lot of hardware out there was not for high performance because of the way it was electronically connected.
Yeah.
Disk drives are going through some sort of multiplexer in terms of getting the signal, and so we were curious and we figured could we design a system that is enabling high performance but using low performance components. So in this network attached server, we have basically 12 bays. We are only consuming 100 watts. So that's like
Hmm.
1/10 or 1/20th of the typical servers that are converged. We are under 20 decibels, which is less than a refrigerator in terms of noise
Wow.
emissions.
Uh-huh.
And our CPU is only a 10-watt embedded CPU, and we have 32 gigs of RAM on this particular one, but typically we can go down to even something that down is like 8 gigabytes of RAM. And what we're showing here is with the Vault file system, these spinning disk drives can have really high performance of speeds,
Hmm.
gigabytes of speeds from using the parallelization. In fact, just adding three of these disk servers, we're only up to 300 watts. So you can plug it
Wow.
into your normal office. It's still quiet under 20 decibels, and you have a petabyte of storage in your office.
Yeah,
A
that's
petabyte,
quite a bit. Yeah.
yeah, most dental clinics, most medical center, small clinics will not have anywhere close to that, but they will be able to build something with higher data resolution if they wanted to,
Hmm.
keep patient records longer,
Yep.
meet regulatory requirements of security of the
Hmm.
data, because data at
Right.
rest or in flight in our system is always secure by the nature of how we manage the data.
Right, right. And I've seen the needs for this up close. Earlier this year, I had taken a tour. I have another show that I do, and I went there with a film crew. And my friend is the admin at the University of Washington's William Myron Center for Neural Signaling. So it's a microscopy center now. And that's where they do multi-lattice biofluorescent dye injections to actually see cells in 3D and actually take animations of it. And they have to store a lot of data there. And in fact, they use a lot of machine learning too to help map out once you have all these images acquired, and the technicians and people will come in, and even students will come work on the equipment, and they will go through and they have to store so much data as you could imagine, as it's 3D and high def, and you know, very very in-depth scanning for living cells, like in vivo, in fact. And so
Yes,
I've seen
yes,
so many needs for this. And if you want to say, well, how about a video game studio? How about a film studio? How about
right.
a music recording studio? Depending on how they're recording and how much they're recording, this is a boon to all small mid-sized enterprises out there.
Yeah,
And the bigger you are, the more you're going to save too. And you're going to have so much out there that you actually have to back up and back up and back up the bigger you are. And this really goes a long way. Plus, again, everything here is like a whole order of magnitude under the norm right now. That's a big deal, also because
right.
it's cooler, things will last for longer. Looking at a better car all the way around. It's
Yeah,
performance balanced with resiliency, and in a way that again, have never seen any raid situations ever sport this, much less in an automated way, and also
right.
with non-matching drives, like it's we've come a long way, and you guys have brought us here. So,
Right. Well, so I
yeah.
mean, you're talking about SMR drives, which is our latest
Hmm.
announcement. It's important to know why that is becomes important, and that is that the march towards higher and higher storage density brings us to new technologies. I mean, there's HAMR, heat-assisted and magnetic
Oh
recording,
yeah.
and that allows us to use make the dots where data is recorded. It's much tiny or
Mhm.
more very close, I guess, fabricated or parts that are much closer together.
Oh yeah.
But basically, you can over using SMR, shingle magnetic recording, you can make them even higher data storage density, and that's kind of shown graphically here.
Hmm.
On the right hand side is this the conventional magnetic recording CMR. You see
Yeah.
the tape, the sectors, sector
Mm.
one, two, three. The tracks are laid next to each other. So
Yeah.
track one, track two, track three, track four, and so that is the standard way to do it. In shingled magnetic recording architecture, on the left hand side, you see the same sector, sector one, two, and three, but now you see the tracks are overlaid on top of each other, and that gives you a 25% bonus. Imagine, your favorite product, but now with 25% more, right?
Hmm.
And that has been the luxury of a lot of the hyperscalers like AWS,
Right.
Microsoft Azure, or Google Cloud,
Hmm.
because they enjoy this because they worked with the manufacturers, the OEM manufacturers, to build a workaround on the buffering of the data
Oh
that they
yeah.
need to write to these drives.
Hmm.
And
Yeah.
what what is the miracle of Vault file system is that the way we manage data, it works naturally with these disk drives. And
Mhm.
so not only do these hyperscalers enjoy 25% bonus, but they had to do all these workarounds. Now anybody can get this 25% bonus without having to do any kind of extra cost.
Hmm.
And they get all the other bonus benefits that we talked about: self-managing data, self-correcting,
Hmm.
and high speeds, performance, and stuff. And I showed that kind of here, just with a couple of drives. So the bottom x-axis, you have one, two, three, four, five disk drives
Hmm.
working in parallel, and so this is the left-hand side is write speeds, and the right hand is the read speeds. And you can see just with four drives, we're getting down up to a gigabyte of speeds of data performance, reading speeds and stuff.
Hmm.
And so the more drives you put in parallel, the faster will your data performance be for your system. And that
Yeah.
works really well for AI training at the edge, because now
Yes,
you
it
can
does.
store lots of data that
Hmm.
you're collecting, your archive data of the entire company's portfolio, and basically you can keep data sovereign
Hmm.
and use it for AI training and inference that you might want to run in your company or in your organization.
It's so valuable. It's so valuable to be able to do this, and without needing such a large investment to do it. For those of you out
Correct.
there who need it, you know this is a game changer. Okay, so I know I have a lot of need for this in my life as well. So
So yeah, that's basically the applications that we are
mhm.
excited about are also take us to the edge. So we have
Yeah.
a very
Hmm.
we have a very exciting project that we said, well, a majority of the world is not participating in the data economies because of the fact that they're just very difficult to manage data. There's not enough electrical infrastructure to host these megawatt data centers. So why don't we bring the data to these individuals, these organizations and communities? So
Hmm.
in the US, you have rural communities with rural hospitals that want to become more digital, but they don't want data to be accessed from a a major cloud operator that might be very far away. So it's because there's latency and data governance and sovereignty issues. So we bring the whole container that's basically a built-in data center that can be fabricated in 24 weeks by our partner Kaiser and Blade Room. And basically it consumes 100 kilowatts. And with our disk drives and servers in there, they're consuming only 300 watts per petabyte. So you can see the majority of the energy kilowatts, almost 100 kilowatts, is still
Uh-huh.
available for all the other operations that might want to do at that data center.
That's
And
right.
so Kaiser and Blade Room, they manufacture it with labeling as the most sustainable data at the edge. And you
Hmm.
see it's a self-contained, rolls right off the truck onto and installs in your site in 24 weeks, basically,
Hmm.
and gets everybody connected. So we're very excited about this partnership, and we hope that as we grow, we can bring it to the rest of the world, basically.
Yeah. Ah, that's incredible. And let's go into your slides. Let's go back a few. some side by side comparisons. I definitely and look at yeah, there we are. Go ahead, go back one more to you were just on it.
So
That's it.
good.
Oh yeah,
Okay,
this
yeah.
is the winner. Okay, so if you look on the right side, you'll see the Swiss Fault Tower unit. Okay, and of course you can see the energy per watts used, and then the for you a rack unit on the left. Again, even more than a whole order of magnitude less in energy use in watts. And again, a way smaller footprint, cooler. It's much more quiet. And look at that. It's such a huge savings. I like to look at all the varieties of appliances that you guys produce, and it's exciting to see because it's just a new wave and like a way beefier, more powerful NAS. But again, a totally different animal. In fact, like with all of its automation and
Right.
capacity savings, it is different. It is a performer. So,
We designed this because we had an idea. Uh, the world is still struggling with data. They'll continue to struggle with data. But the customer that we were thinking about that we're really empathetic for was the hospital. The hospital is usually in the inner city. They don't have a lot of space, they don't have a lot of power, and they don't have a lot of people to manage the data center. So we said, how can we reduce the complexity altogether? So you're quite right. The Supermicro here shows 48 disks, the
mhm,
fan, the power supply, the compute,
yeah.
and the element. And we designed a printed circuit board where we could do the 48 disks, but we significantly reduced the volume by taking everything on the back, putting it on the printed circuit board technology that we had designed.
Mhm,
And so we reduced the volume from 57 down to 7 liters.
mhm.
57 liters down to 7 liters is an eightfold reduction in size, also weight, and also sort of the noise emissions that might come with it.
Yeah.
And by just using component parts that were that could manage the operation with compute on board as well, we were able to reduce it down to 120 watts, not down to even
Mhm,
more than that, less than 100 watts now.
mhm.
And that is with the lower energy use, as you mentioned, we can
Mhm.
have less heat emissions, so you can have this in the office. And this is exactly what I travel with. We took it to
Yeah.
the IEEE conference in San Diego. We demonstrated there. We won the most sustainable technology award
In the universe.
um, from
Like-
from IEEE. So we won the
Yeah.
most sustainable award from IEEE, and so that was a quite
Uh-huh. Oh,
yeah.
yeah, yeah. Absolutely. I
So
mean, and
that
think about this. I mean, look, there's no water liquid cooling involved. It uses very quiet fans.
yep,
And
yep.
you're not dealing with the same hotspot situations that you would in certain other types of farms,
And
it's incredible that you can travel with this as well.
yeah, I usually plug in a power meter, and I show that it's consuming like less than 50 watts, basically, sometimes
Mhm.
when it's idle. And of course, I've taken it to all the way across Europe, Berlin, Athens, Zurich, and then all the way to San Francisco for presentations, and
Uh-huh.
and London as well. So
Yeah.
it's been traveling with me and still working like really really well. So
I love that. It's so cool. I just love it. Yeah, and it holds a lot too. So, I mean, that's
um,
sporting, yeah, 48
well,
discs.
well,
Uh,
48 discs times by the shingled magnetic recording drives that we
mhm.
talked about, which are at 32 terabytes. So 48 discs at 32 terabytes, that's already a petabyte and a half,
Yeah.
1.5 petabytes in this small form
Mhm.
factor, which is 10 centimeters by 15
Yeah.
centimeters tall and
Right.
43 centimeters wide,
Uh-huh.
right?
Yeah, and the fact that the way you guys license this out is extremely sensible, and just it's so approachable, and no matter what your budget is, really.
Yeah.
I just the savings just speaks volumes. Like you'll have room to wiggle around and do whatever you need to do at that point if you're adopting Swiss Vault. I can tell you that much. And you guys have actually been and let's also talk about some of the compute options that are coming up now. And I don't want to derail your presentation too much, but I definitely want to make sure we touch on that combined force of compute, be it GPUs, if someone should choose, or NPUs, neural processing units, which are
Yeah.
way more effective for inference and use even less power than GPUs, which are great for training, don't get me wrong. But for the majority of people out there who do use AI as a tool, as we do with chats and things like that, you're using inference mostly. And there's no reason to, again, take a big truck to the corner store for a stick of gum when you could just ride a bike, right? So efficiency is key, and what you guys have optimized here is incredible. So
You're quite right. I think the predictions are that once you train a model, like the Llama model that's available from Meta and
mhm,
becomes open source, a lot of people can actually use that model for most of the work that they probably need to do.
that's
And
right.
so,
Yeah.
so you get these small models that'll be
Hmm.
available. You can run on the edge. And in fact, we show that we can run it with a 10-watt CPU in
Hmm.
memory, 15 billion parameters, and works just fine. And the reason it works fine is because our file system is shoving data in parallel, so there's
Hmm.
no downtime whatsoever. It's using high CPU
Hmm.
performance,
Oh yeah.
and basically we can run it really quickly and energy efficiently than using a high power GPU on the
Yeah.
edge.
At its core, because you need your storage and your compute together when it comes to training and inference and things like this, and knowledge bases and whatnot. I mean, if you're a company, I'm sure a lot of people are having some great ideas right now on what they could do to refab and change things with their environments, right? Because if
Right.
you're looking at a distributed file system and that you can run around the world literally, then you have, locality, you have data availability in regions. You have,
Yeah.
again, that backup that we all talk about and that parity chain around or in the system. It's phenomenal. So, I mean, there is that. I mean, you guys have been involved in a lot of really great projects to help people, though. I know you were involved in South Africa, in some efforts set up. I think there's a hospital there as well. And these are important pain points to address. A lot of people out there, and me including myself, we all love some sci-fi, and we're looking at the world around us right now in present days. It's incredible the type of things that technology is getting us. Um, but as it goes, humanity first. People matter. Health matters. Food matters. We're not just like, oh, let's get to artificial intelligence at a level that's AGI or whatever, super intelligence, or let's, build the most killer app. Like, let's help humanity. How about that?
Mhm.
And that's what you guys have
Right.
been doing the whole time, that I've known you and seen your presentations and the talks that we've done before. Have always been far-reaching and just so important for people to know about and to think about because again, someone who has two offices now can connect them and have these units between two different physical locations, and as their business grows, they can just scale out easily. Take a moment to talk about Kwai AI. That's KWAAI dot AI. Riza Rasul, the retired CTO of the Real Networks here in Seattle, he actually founded Kwai not long ago, about 2 years ago, I think. And I've been a member for a year and a half or so. And we are focused on democratizing AI and providing people with data, sovereignty in a way where they have access to basically public compute infrastructure that we've created, using our QuiNet. In order to load level the compute resources out there. And so, if you had a computer at home that you wanted to just add as a node, you could do that and then participate in that and serve like medium small models that are open. And then, in different places of, again, all the way around the world, we have Quinet running. And when I brought you guys to the table last year to take a look at what we were doing, it quickly became sponsors. And now you're hardware sponsors to the degree that you guys have one of our nodes running up in Vancouver, BC, last I
Right. That's
checked,
right. Yeah, we
It's
have one in
incredible.
Canada running. Yeah,
Yeah.
one of the first international ones
Yeah.
running in Canada. And
Uh-huh.
I think Kauai is a model for basically how AI will grow. There will be people who will want to run AI applications at the edge. in this case with Kwai, is basically for education. But you
Hmm.
can imagine an automobile shop trying to do its books,
Yeah.
or maybe a flower shop trying to run orders, and so these are people will be benefiting from AI
Right.
models
Uh-huh.
that they will acquire, and they want to be able to run it at the edge. And so we think that Kwai is basically a forerunner and of all great things to come. Yep.
That's right. It's a multitude of case studies, from education to health to science and just the open source effort that it is. And we're up to almost 900 members now. We're really
Nice.
fortunate to have you as a sponsor and just as someone at the table with sensible perspectives on what can be done and how to do it. But think if you're a small operation, this again for a SaaS operation or someone who wants to supply like hundreds of thousands of users with their killer app out there, they're going to be using cloud most likely. They're going to be using something
Yeah.
like we said, GCS, Azure, AWS, Oracle, perhaps. Uh, Maybe something they create. But if you make your own on-prem installation for internal use, it makes so much sense because hey, here's 20 years of our company's data history with clients, okay, and we get a data scientist and some people to put this together into a pipeline, and all of a sudden we're using it with our AI internally on-prem. Securely, and it's not for anybody outside to get to it. You're not trying to supply again, thousands of users. You might be supplying compute for 50 people at a time, and maybe only a handful of those are really using it for analysis and whatnot and business uses. So it depends
You're
on
quite
your
right.
your
But
setup and your company. But
we have already a good model. We have a good model
yeah.
that's all the AI, the apps that run on smartphones,
Uh-huh.
and
That's
they're
right.
using the data that's local on your, like, I create little videos of the video
Mm-hmm.
pictures I collect on my trips and stuff.
Mm-hmm.
And so, I mean, that app is running on my phone and it's not sharing the data beyond that. But basically, that's how we can imagine the next generation is going to be AI applications or AI agents that are going to run locally that you're going
Mm-hmm.
to download from somewhere,
Right.
and then you're going to configure it so that the data is
Uh-huh.
not shared, and you basically would be able to run your operations from there. Get
Right.
sensor data. The projects that you alluded to, which we are part of, are very large European consortium projects.
Mm-hmm.
One is for smart wound monitoring, so there's going to be sensors everywhere. In the smart city, there will always be sensors that are going to be measured for the health of the building, health of the plants that you have, or the health of the individuals, the human beings living in the
Mm-hmm.
building. So we have sensors for wounds, sensors for heart monitoring, and people will be able to get faster health care based on their vitals that are being monitored. And in
Mm-hmm.
the case of the wound one, that's a very exciting project. The wound at the wound site, there are biomarkers that correlate with the healing of the wound. And seniors, our elderly population, they may get lower leg wounds that will kind of open up and you have to put a band-aid on it. And
Mm-hmm.
every day, every other day, you have to show up at the hospital, remove the band-aid, check and see if it's healing or not, and rebandage it. But with the smart wound, the proposal, the potential is that it tells us already whether the wound is being healed. Where the temperature goes up, whereas the wound is healing, and then it comes down in a
Mm-hmm.
particular site, time, when point, and a couple other biomarkers that can be measured. And we're doing that project with being sponsored by Philips Healthcare, with Essity and Infineon, and they're
Nice.
enabling us to use our
Uh-huh.
device to measure the data from the sensors.
Mm-hmm.
We're looking at developing an AI model that will be able to tell us whether, should a doctor be notified if something's wrong, or whether everything is going as per plan, or the wound is
Mm-hmm.
actually healing in a timely manner. And that means that the less invasiveness or of removing the band-aid and
Right.
fixing it
Yeah.
again by a nurse,
Uh-huh.
it'll reduce the
Yeah.
cost, increase the
Uh-huh.
comfort of
Yeah.
patients.
Again, the Internet of Things, be it a plant that it's growing or a manufacturing plant or a person that's healing. I mean, there's a great need for this higher, a more, a closer access to the data, something that's local, something that's
Right.
fast. And then again, I want to put this out there too, because all that we're talking about, no matter how much drive speed changes and capacity speed advances, Swiss vault is, I would say, a necessary part in future operations that are on the edge. You cannot find parity integrity that high anywhere in any file system that I have seen yet. And I've seen a lot. And I love the hack and I love working with file systems. And I've built file systems from scratch myself to do very particular things. Um, and so I have a lot of heart in this, and so it's always fun when we get to like really prod and poke at like what's available and what is possible, right? Because again, if you said like a long time ago there was Fuse FS, and this is like a decade ago, I think, and you could have different USB sticks and you could run the file system across all of them and have parity and even like USB sticks. It was so funny, but it was an open source project. But
Yeah.
that's how a lot of things happen though. And then you have people like Dropbox. Shoot, they adopted, and I think it was 2018, the SMR, shingle magnetic recording technology
Yeah.
themselves. And they really helped give them a
Yeah.
boost. And so we can see in plenty of parts of just what you guys do as a case study already works. You put it all together, and we've got a new
Yeah.
animal. We've got a new way to manage the future of communications. And I think that again, mathematical optimization at all points is a clear winner because you're not brute forcing it. You're not holding the
Right.
hammer close to the head of it. You're holding it at the end, where you need to hold it. And it's just
Mhm.
maximization of everything you're doing, and we need this. This is frugal in the right ways and while providing resilience. That's amazing. But then it's high performance while maintaining a green edge, you
And
know,
low cost. Yeah.
and then the low cost. So it's like, they say, cheap, was it cheap, fast, and good and quality. Pick two. You're
That's
not
right.
getting all three.
You're not
How
getting
did
all
you
three. That's
break the
right.
rules, man? You guys broke the
We broke the
rules.
rule.
Like this is
I gotta remember that one. That's right. That's true.
yeah, but it's true. And I mean, and you guys you make it accessible. And again, this is about democratizing access to hardware potential, making projects that weren't possible approachable, and
Right.
making what we already have out there way more efficient. You could just take, if there were no more developments in technology right now, and everybody implemented Swiss fault where it mattered, in these bigger situations, and then on the closer on the edge as well, we would have cut down a fair amount of emissions, and
Correct.
I feel like it should be, it's only a matter of time before more people start adopting this. Again,
Mhm.
I brought Swiss Vault to the table, and when we talked about a lot of technology in Malaysia, I bring it up in a lot of other cases as well. And every so often, I turn around and there's a press release, and I'm like, oh, time to go let people know because we've got something else moving. So,
I really thank you. I mean, you're quite right. I mean, the work that we need to that's ahead of us
mhm,
to be able to tell people about what we're doing, which is more efficient, saves money, saves the environment. It brings a lot of benefits overall to marginalized communities that are not able to participate in the
mhm,
data storage economy. They're all still thinking in the old paradigm. I need to build this megawatt data center. I
mhm,
need to commission these massive networking or power supply components. And we're saying, no, you don't need to do that anymore. And
mhm.
so, but we need to get the word out. And
That's right.
I
Yeah.
think,
It's the people that, and to the people that are already doing this type of stuff would save a ton of money and other things, to start implementing it on their given hardware. And the people that are about to make a decision might want to think about this a little bit and see about talking to you and your team, about getting a demo, and that's the
right.
thing, is that we do demos. There are ways of getting this going. You're a globetrotter. Every time I catch up to you, you're in another state or country or province. It's awesome. One day we'll be on the same stage. I know it.
We should. We should aim for that soon. I hope that we can do that soon, actually, because
Yeah, yeah.
I am trying to pick up more of the sort of the trail for trying to get reach more customers, more
Hmm.
more partners, and trying to go to bigger conferences now. AI
Hmm.
is now big on my radar to get to,
Yeah.
and because now the crescendo has worked up to where how do we host this data? How do we get
Hmm.
data privacy? And now we have the solution. So I I want to be able to talk to people that really care about this and work with them.
It's you guys deserve to be the hype wave. in all this, right? I mean, this is like this is a real, savings in every way. And whether people are adopting AI like hotcakes or not, like this is a real hype wave that needs to be known about. And the earlier whoever starts adopting Swiss Vault sooner than later are going to be saving money sooner than later. And if you're a competitor in,
Yeah.
data centers, then try this out. What, are you going to save some money? Oops, go do this. It's provably a sane choice and a scalable one at that. So, do you have any other visuals or any other types of
Well, I mean,
projects you'd like to share with us today before we go?
the one that I'm pushing on is primarily on the infinite storage, basically.
Oh yeah.
And we're working with some partners to be able to launch this. The idea that we can help most organizations store their data for 100 years. And basically, I'm working on the white paper right now. I hope to get that out in a week or so, just before September, to
Hmm.
basically get on a campaign to talk to people about, hey, you don't have to start limiting the volume of data that you need. We want to help you use all the data that you can to build your best of your AI applications out there. And that means that we are able to do data on-prem that is basically self-managing,
Hmm.
large volumes that you can grow to, and reducing your costs, but also increasing your speeds. So
Hmm.
this is where we are really excited about the next phase of the launch,
Hmm.
and we're assembling our partners to be able to do this. And I'll be excited to tell you a little bit more about it in the coming weeks. We'll see if some more press
Yeah.
releases coming out from us.
Uh-huh. Right.
So we're yeah.
I really just need a Swiss Vault appliance in my home.
Well,
Uh,
you'll get one. I'm sure you'll get
yeah,
one.
we're gonna get one. I'm gonna work my way up to it. But anyway, it's so great, because also I think if you're a developer out there, when you're working with other APIs with different AI, foundational model, folks, things change and it's outside of the bounds of your control, and all of a sudden you're having to scramble and change code and do different things. But if you run your own on-premises compute and storage, then no one's updating anything without it being you. All of a sudden you have the consistency of it not changing.
I mean, basically, I mean, to deliver this
Hmm.
promise of compute everywhere for 100 years, compute or storage for 100 years, I mean, we have to figure out how to get it to people. And we keep thinking about that you have to simplify everything,
Hmm.
reduce the complexity all across the board. And that's because we came at a tangential sort of angle to the rest of the industry. We didn't have any holy cows to consider. We just started designing from scratch based on principles that we wanted, which was low energy, low power, low noise, easy
Hmm.
to use, low weight, and small size. And
Hmm.
how can we get it down to this kind of? So in the end, we ended up succeeding. And our idea about getting it to the rest of the world is basically that we don't want to manufacture these systems. We can, if it's so simple to manufacture, then any OEM or anyone who can build a printed circuit board can basically manufacture this system in Nigeria, in
Hmm.
Botswana, in Peru, and basically
Yeah.
deliver it to the local organizations there that need data storage. And
Hmm.
then because they're doing a local delivery, they can service it there, they can recycle it,
Yeah.
and basically we're reducing the carbon emissions footprint dramatically.
Hmm.
And
Yeah.
but by then, people will be thinking, how can we reduce it even further? And hopefully, we're further along this into continuously thinking and rethinking about how we're storing
Hmm.
data.
Yeah, yeah, I love that part too. Like from start to finish, it's green. You're already
Yeah.
thinking about component level recycling. You're already thinking about like longevity at every step. And it's doable. It's just approachable. I mean, it's daunting for some and probably for everyone once they start doing it, right? But it's still again approachable.
So
Yeah.
we'll start to assemble lists of people, lists of
Hmm.
organizations that would love to do this, offer that
Hmm.
local service
Yeah.
and local build. Spoken to several already who are on board,
Hmm.
and I'm going to be start announcing those in the very near future as well.
Are there any what's the next convention that Swiss Vault will be present at, or what's something that you're going to be involved with next?
The team is everywhere, but I'm definitely have supercompute on my radar in
Mhm.
November. Supercompute 2025 is going to be in St. Louis.
Okay.
Yeah, so we meet a lot of our partners there,
Uh-huh.
and we'll have a couple of big major announcements with major OEM partners as well coming up very soon.
Hmm.
And yeah, so I'm excited about the September coming up. But the struggle for startups is how to grow in a sustainable way as well. And
Hmm.
that's why, as in my role, I'm more focused on helping the team grow and get the capabilities we need to continue to grow. Working with you, it's been a delight. I mean, in fact, you put us on the road as well for on AI when we met. We were, we were still struggling with just managing data and talking to customers about data management. We had completely kind of almost missed the whole AI problem that were emerging. And you working with your AI podcast back then when you were at MIT,
Hmm.
we were in the MIT program. We were like, wow, this is there's a whole community here that really cares about this, and
Oh
and
yeah.
because of you, got plugged into it
Uh-huh.
and started to really pay attention.
We had it down to 6 hours, I think, when we had you on the show. And so I know Joe Suppers and I
Amazing.
know Doug Fortune out there. They're hard workers and have done a lot. I know Doug's up in Vancouver, BC, and I know Joe's out there in Jersey. But you guys are just such a compact team and get so much done. But yeah, we brought you. It was Egla Thomas that brought you to the table, and I said, "Well, sure, we got to hear about this." And everybody who worked in healthcare, uh, people with the government, people in pure data, people who have worked in data centers, like everybody was floored. And then even to this day, I still get messages from people, "Hey, can you get Swiss Vault to come talk to us again?" I'm like, "Yeah, okay." So we've got this recording, right?
Yeah,
And but you're right, because I mean, it was perfect timing. The hype wave to me has nothing to do with AI. I'm like it's substantial, and it's the data necessity. And even if AI never existed, we'd all still be taking pictures, and we have higher definition videos coming out every few years, and new standards. And it's always a race for more capacity or, higher resolutions. It's just natural, we do this as humans. But in the evolution of things, here we've got Swiss Fault to enable it, an actual vehicle to get you there. Even as if you just froze that and said, "Oh, no more innovation," you've got a perfect system for this. So you
right.
could always, polish different things out there in the interim. But as far as it stands, I mean, it's green in, green out, green up, green down. You don't. There's nothing inefficient about it. And again, reasonably
Green up,
approachable.
green down.
Yeah,
Green up,
yeah.
green down. You're right.
It really is.
Thanks
Yeah,
for having me on the call and great to connect with you. And I always love to give you
yeah,
updates and also
yeah.
pick your mind about
Uh-huh.
what else is cool happening where we can work together and
Mm-hmm.
where we can solve problems. So thank you very much for your guidance
Yeah.
throughout and advice and stuff and your
Uh-huh.
support.
Yeah, absolutely. And we have a lot of work to do ahead, and there's a lot of improvement we can do in this world. And I'm here for it. Big thanks to Doug Fortune and Joe Suppers at Swiss Vault. You guys are always working tirelessly to make wonderful
Yep.
things happen around the world. Thank you, Bhupinder, for taking the time. So this has been the AI Think Tank podcast. I'm Dan Wilson, Bhupinder Bhullar. Thank you so much for joining us, and we'll talk soon. Thank you so
All right.
much.
Bye bye.
Bye.